Hello, everyone. Welcome to our December RioSense webinar. We have the R&D team, sales team, and a field service engineer joining us in the festivities. Today is going to be just a fun webinar where we sort of do a demonstration on our m-VROC. And the materials we're going to test today are going to be coffee and different sorts of holiday creamers that you might want to add. And we'll talk a little bit about the instrument, our technology, and science behind coffee and cream. So I'll pass it on to Rick, who's going to give us a quick overview. He'll introduce himself and give a quick overview on the RioSense technology.
Hey everybody, I'm Rick. I'm part of the sales team. And a quick overview of our technology starts with v-VROC. That stands for viscometer and rheometer on a chip. And so our technology is based off of those two separate technologies that we've combined into one. The microfluidic channel allows us to test very small sample volume, and the flow-through design helps us to reach very, very high shear rates. So now you can begin to look at samples beyond what you could probably see with rotating systems. Now you can look at non-Newtonian behavior that you might see in injectability studies or manufacturing processes. So the technology itself, as I said, is microfluidic, and embedded in the microfluidic channels are pressure sensors. And we use a derivative of the Hagen-Poiseuille equation where shear stress divided by shear rate gives us dynamic viscosity. And the shear stress is proportional to the pressure drop. And so as fluid flows through the channel, we get that pressure drop. We can control shear rate very precisely by knowing the exact dimensions of the chip. We use a positive displacement pump. And with these two, we get dynamic viscosity with very, very high repeatability and accuracy. And on top of that, we are able to use the WRM correction on any non-Newtonian samples. And so you're also getting true viscosity. So at this point, I'd like to introduce the rest of the team. So we have our application scientists, Christian and Marina. We have our technical sales specialist, Ashley, there. And we have Wayne, who is our service engineer. Okay, so at this point, I think what we could do is we can begin to look at the different samples that we'll be testing. And so Marina, you want to go ahead and start that?
Yeah, so today we have Starbucks coffee. We have a large jug of it today. I'm going to be making different combinations with some like common creamers that people use, and we will also be testing one of the creamers by themselves. So today we brought Califia Oat Barista Blend. This was so no one would drink it. And we also, this is oat-based, so it's an oat-based product. I guess it was made to replace using heavy cream for people who have dairy sensitivities or other dietary restrictions. And then we also have heavy cream here today. It's from Clover, very delicious brand, I have to say. This one is all cream. There are no other additives to it, so it's just pure heavy cream. And we have in this lovely cup creamer from Starbucks that we got with the coffee today. Without spilling. Yeah, looks just like heavy, irregular cream. Yes. Want to make sure. All right, so first I'm going to hand Rick a cup of just black coffee, and he's going to demonstrate how to properly load the syringe. Yes.
So our technology is a pump-based system, and it's a very simple instrument to learn and to begin your viscosity testing. Basically load a syringe, you place it into the syringe holder. The syringe jacket is what we call it. Once you clamp it down, you're basically ready to do your testing. So here's the coffee.
And then in the meantime, I'll give them some to our taste testers over here who can comment on the flavor.
So you basically just take your syringe. I've attached a adapter so that I can get into the coffee a little bit easier. And one thing that you want to be careful about is to not pull up or to watch out for air bubbles. But the air bubbles are actually quite easy to remove, and we have a nice tutorial on that on YouTube that you can check out. But anyway, air bubbles are quite simple to remove. If you find that there is an air bubble, let's say stuck at the base, you could just flick it down in this motion. And then you can just push up the air, the bubble through. Then you can actually see it coming out the top here. Once that air bubble is out, you have a nice syringe with only fluid. So right now, Marina is getting the other components ready. And, maybe at this time we could actually taste the coffee. Would that be all right?
Yes, you guys want to take
Kind of like a baseline measurement, so to speak.
Yes.
Pretty watery, so I think the viscosity is going to be low.
What do you think the viscosity might be?
I think it's between 1 and 2 centipoids.
Okay. And what is that? What would you say is a good reference for that?
Well, 2 centipoids is about the viscosity of IPA,
Mhm.
and 1 centipoid is about water. So I'm thinking somewhere in between those.
Okay. So quite low in viscosity.
So we can go ahead and test the coffee now
Okay.
on our lovely decorated m-VROC here.
All right. Again, very simple process. We have a syringe already loaded in there, but now we're going to be testing coffee. Basically, just screw it in. Once it's screwed in, put it into the syringe holder. Move your pusher block to the end of your syringe, lock it in place. Open this up. This will open the valve. Close your syringe jacket. And, within 30 seconds, you're ready to go.
Maybe you can make a quick comment, Rick, on what's already in the flow channel and, tips on what should be in there as you displace with your actual sample.
So right now, I believe there's just
We have 1% aqua.
1% of in there, which is 99% water, 1% detergent and surfactants. What we have to be careful about is how the samples will interact. And so we make sure that the samples are miscible with each other. That way, when you test one sample, if there's anything inside of the flow channel, nothing will crash out. And so that's easily done just by testing the two mixtures together. You don't see any precipitation and you're ready to go. Okay. Now, once this is ready to go, Christian will go ahead and run the test using the software that's provided with any purchase of the instrument.
Hi, everyone. So we're going to be using this intuitive, easy-to-use software. So the first thing you have to do is input the name of the sample. So here we're going to input just black coffee. Follow in the next line and ask you to give an estimate of what you think the viscosity would be. It doesn't have to be too accurate. So I remember that Ashley mentioned it's around 1 to 2 centipoints. So I will place 1 in that slot. The next row is to indicate the volume that you loaded into the test syringe. So that test syringe is for 1,000 microliters. So that's what we're going to input there. And make sure to select the syringe size you'll be using. So we have selected 1 milliliter syringe size. The next step is to select the shear rate you want to run at. So for this measurement, we're going to select the shear rate of 10,000. And the software will automatically generate the measurement time and pause time for you. So here we're going to adjust the measurement time to 20 seconds. A little bit more than that. And after that step, we can go ahead and go to the bottom right to pump control. And you're going to hit clear So the pump control would be to clear the stall, but at this step, you're going to hit this button here to pretty much get this block here to make contact with the pusher, with the piston. So here it's telling me that the plunger is contacted, so I'm going to click OK. And then the opposite to make sure this is not contacting the plunger anymore after your measurements. Then you go to the bottom right and select clear stall. So at this point, you can go ahead and select start to start the measurements. And we're going to see here the 4 plots that will populate with your results in real time as the coffee is measured.
So as the coffee is displacing the fluid that we have in there, the aquat, the graph might look a little interesting because there might be a dip. But it looks like this is.
Yeah, it looks really good. So we can see here the viscosity versus time plot on the top left. It might be a little blurry on your end, but here we can see that the viscosity is pretty stable at around 1 centipoint. On the bottom left, you can see the pressure profile along the base of the channel. On the top right, you can see the temperature variation with time. So we have a pretty even, steady temperature. And on the bottom right, you can see the viscosity plotted with respect to shear rates. So we're only doing 1 shear rate, and so that's why we only have 1 data point there. But if you're running a shear rate sweep, you will have the entire, all the data points for all the multiple shear rates.
Yeah, and since there was still some other liquid, the aquat in the channel, I generally would recommend running it a second time just to make sure we completely displaced all the previous liquid that was in there, just to make sure we get an accurate measurement. Because sometimes when there's 2 fluids in the channels, they can mix, and then that of course will affect the viscosity because it's not just 1 liquid, it's a mixture of the 2.
Another way you can visualize your data is to go to the result summary. So here you'll get this table showing you a lot of the parameters you saw in the data graphs. So this shows you the segments followed by temperature, and it gives you some more detailed explanation of the pressure drop along the channel, the flow rate at which you were running the measurement at. So this flow rate is 529 microliters per minute, which corresponds to the shear rate that we selected. You can also see the shear stress, percent full scale, and the shear rate you selected, and this viscosity value of 1 that we got for the coffee sample. To the right of that, you have 2 columns for true shear rate and true viscosity. So if you select the software to give you the WRM correction, you can the software will give you the true shear rate and true viscosity for shear rate sweeps. So this is very helpful for non-Newtonian samples, shear thinning samples, to get a better idea of their viscosity profile of these samples. And then the last column is the slope fit of the pressure profile. So that's the testing for the first coffee sample. It looks very good. Should we continue to the next?
Yeah, so the next one we're gonna do is we're gonna use our lovely heavy cream here, and I'm gonna make a roughly 20% to 20% heavy cream to 80% coffee mixture. So I'm just gonna mix it a little bit. Some samples might be inhomogenized or unhomogenized, so it's important to mix everything first before you test it. So we're just gonna mix the heavy cream a little bit. Especially natural products, they tend to settle. So I'm gonna mix it in a cup, and then I'm gonna hand it to Rick in a little bottle like this, just to make it easier to mix everything.
And we don't need to run a cleaning agent through the channel before we run this because we are running our sample with, we're gonna think of coffee as our buffer for this. And so it's basically like adding proteins to your buffer that you have just primed the chip with. So we're good to go on our next measurement.
Yep.
There, I'm gonna mix it one more time just to make sure. There we go.
Okay.
And then I will make some for our taste testers over here. 'Cause I can see them eyeing it over here.
They're looking thirsty.
You sure did.
Again, very simple process. Simply just pull up your sample. Once your sample is pulled up, get rid of the air bubble, might be there. Easy technique. Air bubble's now at the top. Just push that through. Oh, it's also important to use lint-free wipes. You don't want to use Kim wipes or paper towels because of the microfluidic channel, and that's a good general rule for any type of microfluidic system. So here is the sample. Got 1,000 microliters in there.
While Rick is inserting the syringe, I'll just mention that if you have any questions, please type them into the chat box. We'd be happy to discuss RioSense or our technology if you're new to it.
Wait, what do we think the viscosity of this one is?
So the first one was around 1.
Mhm.
I do like a 1.3.
Oh,
That's really precise. man.
1.3.
Okay. I'm gonna go more like a 2. I can higher than that.
So we did test the heavy cream beforehand and it gave us a viscosity of roughly 15 to 16, depending on the shear rate. It looks like it does shear thin, which means the shear rate does affect the viscosity of the sample. So it is quite more viscous than just plain coffee.
Yeah, so this is ready to go. Chris, you want to go ahead and start?
Hi again. So here we're going to put the new label, coffee with creamer. And then for the estimated viscosity, I'm going to meet Wayne and Ashley in the middle and guess 1.7 centipoint. And again, for the volume loaded to the syringe, 1,000 microliters or 1 milliliter. We're going to stay with the same shear rate that we selected for coffee. And that is pretty much it. We're good to go. You can go ahead and select start. So this is measuring the baseline beforehand, and now it's running the measurement. And this data looks good. You can see that the viscosity is around 1.6 based on the viscosity transient curve. On the top
Right
left.
in between what
Way
you.
up, I guess.
Pretty good.
Could someone comment maybe on the fact that adding the cream has dropped the temperature of the coffee and how temperature might impact viscosity? Because just to point out, temperature control is available for our instrument, but just to minimize background noise, we're just operating at without the temperature controls. So the temperature of the sample will be sort of as it is when we load it into the syringe.
Yeah, so one thing about our technology is embedded within the flow channel is a PT1K temperature probe. So whenever you do a sample viscosity test, the temperature that you get is of the sample and not of the surroundings. And our system is Peltier, our temperature controller is Peltier controlled, so it's very stable. Our plus minus can be as low as 0.07 degrees C. So it's very precise, and you have the confidence of keeping that temperature very stable throughout your entire experiment.
Yeah, and due to the fact that the coffee is hot, and we added something cooler to it, that might artificially lower the temperature, the viscosity of the sample that we just tested. If we were to wait a little bit and let the maybe get to like room temperature, we would get a slightly different value due to the temperature change.
But just statistically, and looking at the data, you can see that there was a viscosity change.
Mhm.
And the coffee that we first ran was not piping hot, so it is not a dramatic change in
Yeah.
temperature.
That
But-
was,
As Christian can show, it will report the temperature within the chip, so you can know if there was a big difference.
Yeah, we can see the temperature variation was not much based on this plot here on the top right throughout the measurement run. And yeah, like it was mentioned, the viscosity, there was about a 60% increase between the black coffee and the coffee with creamer.
And personally, from tasting, it tastes better, because it's a little bit thicker,
Yeah.
and I personally like it being a little bit thicker. So that's how you kind of notice viscosity when you wake up in the morning.
and I personally think that I need more sugar.
Does anyone have a thought as to what adding sugar to Wayne's coffee would do to the viscosity?
I think it will slightly increase.
I think it would increase.
Well, it really depends on how much sugar
Yeah.
Wayne wants. So there'd be a viscosity versus concentration curve
Mhm.
that as you add more and more sugar, you get a more rapid rise in viscosity. So if he likes it super sweet, then it could bump it up quite a bit.
I think Wayne liked
to my health.
I'll bump a few things up a bit.
So a study we could do in the future would be have 10 different cups with different ratios of sugar in it,
Yes,
and how it increases.
we can do concentration versus viscosity.
Quite without having to use much coffee at all.
That's right.
Yes, yes.
Yeah, for those of you out there that are really sample limited, I think we're only using what, 30, 40 microliters?
Yeah, you need
Measurement.
at least 40 to get through the entire flow
Yeah.
channel out. Yeah,
Mhm.
roughly 40.
The software would have indicated how much volume you used during your test, Christian.
Correct. So if you go to the measurement setup tab, here near the middle, it shows you highlighted in green the total measurement volume that it expects to do during this one run. So here it shows 300 microliters for this run. But that's because I increased the measurement time. If you're using the automatic times, which is efficient, we can see the total measurement volume drop to 63 microliters.
What will be our next sample?
So actually, before we load the next sample, we're gonna clean it out with some
Okay.
aqua. So just like any other sample, when you're changing from sample to sample, you want to completely flush out your initial sample by using a soluble liquid that is compatible with your sample. So we tested beforehand. We mixed some aqua in a little jar and saw that is compatible with what we're running today. So we're gonna flush out with aqua.
Good.
And then the next thing we're gonna test is a mixture of the oat barista blend. And I'm gonna very carefully shake it because I already spilled some on myself from shaking it earlier, so I'm gonna cover it with this.
And an important note of why we're using aqua instead of water. Water has high surface tension and it's going to trap things in your flow channel. Water is not a good cleaning solvent for the m-VROC. And that's why we always recommend using m-VROC, the aqua or something else that is soluble in your sample.
And yeah, we won't be mixing aqua with the coffee for them to taste.
No, that
Not a
would be
good
nice.
idea. Do not attempt that.
So since we actually didn't run this yesterday, I'm actually gonna have them taste it and maybe they can give us an estimate of what this by itself
Oh.
would be viscosity. Does it taste good? Ashley was the one who has tried this in the past.
I'm not sure I've tried it on its own.
Okay, well,
While they're doing that, we could clear out.
Sure.
There is a little capsule.
Okay, so for the cleaning with aqua, you're going to use the same steps we used for the coffee samples. So for sample ID, you can put aquats, viscosity of aqua is around 1, and the sample volume is 1,000 microliters again. We're going to keep the same shear rate for the aqua. So Rick mentioned that there is some space between the block and the piston. So we're going to eliminate the space by hitting this big button there.
so what do you guys think?
That's good.
It tastes good by itself? Okay, that's good to
Yeah,
know.
it's actually pretty good.
Okay,
So far, what do you think is better, the cream or this barista?
Well, I only have the oat in the, alone, with the cream in the coffee, so now I need to test the oat in the coffee.
Okay.
But I think the oat one is definitely more viscous than the cream.
All right. That's good to know.
So I already started the run, it was just one click to start it. We can see here that the viscosity is still at around 1.6, and that's because of the coffee with the cream that was remaining in the channel. And I think at this point, the solution the aqueous solution should have passed through the channel and removed the coffee with cream. And we're ready for the next sample.
Awesome. So I went ahead and made a roughly 20% barista blend to 80% coffee mixture and have it in this lovely little vial here. I'll go ahead and hand that to Rick.
So this one is all three of them or two? The creamer?
It's just the barista blend.
Oh,
and the
okay.
coffee.
Yeah, coffee, okay.
And I also made some for you guys to try.
Yay!
So that's what it 80-20 mix.
Yeah.
Definitely more viscous than the one with the cream. Had kind of a thicker taste. This kind of just tastes like coffee, but
Yeah.
Interesting.
yeah.
So can you like feel a difference in how it goes
The
What do you
mouthfeel.
enjoy?
Yeah.
to your palate?
The heavy whipping cream had a little bit more of a thick. Where this feels more like,
Like what, 0.1?
yeah. This probably is like 1.3.
1.3.
1.3. Okay.
That's my guess. Like a tiny bit more than 1.5.
What is your guess going between 1 and 2?
1.5.
1.5.
You're in higher. Now, one concern we have about this oat milk is that there's possibly some particles in it. So one thing to always consider before you test this sample is your particle size.
Yeah, we also have dummy chips that you could test your sample before running it in the m-VROC. And that's a good way to make sure that it'll actually pass through the flow channel. Our dummy chips are replicas of the actual flow channel, just without the electronics. And it's also a nice way to test your cleaning protocol to make sure that your cleaning solutions are appropriate for your sample. Okay, that's it.
Okay, thank you, Rick. So hi again, in case you forgot what I look like. So we're going to enter the sample name, which is coffee with oat.
Barista blend?
Barista blend.
Yep.
Barista blend coffee. And the viscosity, I will enter 1.4, which is around the ballpark that Wayne and Ashley gave me. And again, we'll enter 1,000 microliters. We're going to keep the same shear rates, but we could vary it if we want. The chip has a very wide range of shear rates that it can probe. So now we're going to hit to remove this gap between the plunger and the block. Okay, so this is telling me the plunger is contacted, and we're going to start the measurements.
Right, and we're being really specific with the viscosities that we're putting in, but we could have easily just put 2 for everything, just to keep it really general. Again, these are just, when you input the estimate, it is just that, it's an estimate. You don't have to be as precise as what we're doing.
Yeah, and if you don't have a me and Wayne, you can use something like a standard that you have at your workstation. If you know that standard's 10, you can use your sample and kind of say, is this lower or higher?
Exactly.
What happens if it's like way off, like you put a viscosity of 8?
And the viscosity is way higher, really?
It's like 1 or
Oh, well, if it's, you put in 8 and it's really 1, you might have chose the wrong shear rate, but mainly what would just happen is you might get not a high enough full scale, and it would just not be it would just tell you to redesign the
Yeah.
experiment. And if it was the other way around, you might overpressure, and that is a safety mechanism, so you don't damage the chip, and at that time you would lower your shear rate.
Yeah, your very first measurement, you'll get data, and then you could use that data from the first measurement to plug in the viscosity that you get to get something more precise. But for the very first one, quick estimate is fine.
And if we go back to the measurement setup screen, and we look at the estimated viscosity, another useful thing about this is that whatever value you enter, the software will auto-generate the minimum and maximum rate that it can access based on that viscosity you enter. So that's a very useful tool if you are not exactly sure which rates to run at. So we're going to replicate this measurement at a slightly higher rate to show you this versatility of the instrument. So we're going to select viscosity. And we're going to hit start. So at this point, you don't have to, the plunger is contacted with the block, so you don't have to ensure that they're contacted anymore. So here we can see the full scale pressure of the chip is around 70 to 80%. And the viscosity again is very similar to the one we got in the previous run. So viscosity is about 1.4 center point. And yeah, that's the kind of stuff you can do with this cool software.
So to sum up, what is the viscosity difference between the coffee with cream, coffee with oat milk?
Well, the coffee was about 1, and then the coffee with oat milk was about 1.4, and the coffee with cream was about 1.7, 1.6, 1.7. So definitely, the heavy cream has a bit of a higher viscosity, which makes sense based on tasting it. But even the oat milk that is more viscous than the cream still increases the viscosity of the coffee.
All right, and the last one we have here, on further investigation, I think this might be milk, but I'm not entirely sure. We have, but I'm gonna have to taste it so we can tell. We have this creamer or milk from Starbucks, and you can see I'm stirring it because shaking it to get it to homogenize would not be the wisest choice to make right now. So I'm gonna pour some for our taste testers here, and they're gonna tell us what they.
My guess is it's whole milk based on my knowledge of Starbucks.
Based on your, okay. Ashley is Starbucks expert.
Yes, it's usually their preset they use, but there are many Starbucks baristas in the audience, let us know.
Yeah. Thank you.
Then while they're drinking that, we can go ahead and run more aqua just to flush out our previous.
Yeah.
It's what?
Whole milk.
Whole milk? Okay. Yeah. All right. So while they're getting that ready, I'm going to make another 20 to 80% coffee mixture. I have some coffee in here that are pre-poured.
My guess is this is gonna be about the same viscosity as the oat milk. Would you agree, the oat milk and the coffee?
I think with the creamer. The one with the creamer.
Oh, you think it's the same as the heavy whipping cream?
This is gonna mix. You mean before or after?
After,
Okay.
because Rick is gonna measure the whole milk with the coffee.
Okay.
You're going more like
After the
1.7?
Yeah.
Okay, no, I'm going the same as like the oat milk. I'm going 1.4. I mean, whole milk should have less fat in it than the heavy whipping cream, is that correct? Yeah.
So I ran this cleaning without mentioning it, but we're cleaning with Aquit, just like we did previously. And that will be followed by the last sample, Marina.
Yes. which is the milk and coffee combo.
Oh,
I will hand that to Rick.
nice. Love that.
So we have to place it first.
Oh, you have to
The
do,
ratio-
okay.
The ratio sheet, so that we can make a,
We need to make our final
it
guess.
could be like 5%.
Yeah.
Which would make it 10.
Yes.
That's viscosity.
Yes, because same thing like the sugar, we could make a concentration curve for you. Thank you.
And maybe while you're loading, Rick, could you comment on your chip selection for today's testing?
Oh, yes. So today we're using our A05 chip, and it has a 50 micron channel depth channel. This chip is optimized to test between 0.2 and 100 centipoid with very high accuracy and repeatability. I mean, even when we're testing, like right now, we're testing just above 1 centipoid. The accuracy and repeatability are very, very high. And so we're one of the, we might be the only technology that can test below 1 very, very precisely.
Yeah, as you can see, all the things we're testing are very close to the same viscosity, so the fact we can even do
Yeah.
repeatable measurements
Mhm.
at this low.
Yeah, we're able to differentiate, I mean, 1.3 to 1.6 centipoid, 1 centipoid.
So what did you guys think?
I brought mine over to my side. Agrees.
What number you choosing?
I'm choosing the same as the O, which
So
was
1.4.
4.
1.5,
Yeah.
okay.
Can we go a little lower?
Okay.
1.3.
I
Okay,
didn't go under.
1.3. All right, shooting under this time.
Yeah.
You know, what's really interesting is that, you know, we're talking about viscosity so low that they probably don't look any different physically.
Mhm.
You could tell, I mean, you could tell the difference when you're tasting it. So even a small change in viscosity could mean a big difference in terms of how your clients receive your product. Okay, we are all
Great.
set.
So I've already set the parameters here while Marina and Rick were loading the sample. I'm going to make sure the plunger is contacted with the block. Okay, that was very quick. So now we're gonna hit start. Let's see what we get.
And while we're waiting for the data to come out, could we just clarify the impact of lowering the temperature slightly? We seem to have a slight difference of opinion there for a moment. Which way are we going to go when we drop the temperature by adding milk, cream, or barista blend?
Well, typically with decreasing temperature, viscosity will increase. And so that's you know, all the more important to have a stable temperature controller. So if you are looking at, let's say you're screening different molecules and they're all very similar, that's something that you do want to control. But for us, we're doing like a real world type of comparison. I mean, you're not going to have a temperature controller when you're in Starbucks. So
Yes.
this is kind of our fun way of doing experiments.
So this sample looks very interesting. The first one was 1.2, right? Or was it 1.4?
The O?
Oh, the oat was
Oh, just the
1.4.
The coffee was 1.1,
1.
and the second one was 1.6.
Yeah.
The third one was 1.4,
Mhm.
and this one is 1.3.
Hey, you were on it.
Wow.
There's a difference between all these different coffees and creamers.
He's a human viscometer.
So you could tell the difference though, right? I mean, if you were to take
Yeah.
one from the other, you could tell the difference.
Like in a blind taste test.
Even
I
blind
feel like
taste.
part of it is because you're so used to the viscosity of water, you can kind of
Mhm.
mentally base it off of that.
Right. I mean, so we're talking, you know, 0.1, 0.2, 0.3 difference in viscosity,
Yes.
but physically you could tell.
But as you can see, me and Wayne had different opinions, and that's why it's so important to test on an instrument and not just kind of guess your viscosity and say, oh, looks like water, because maybe it's not, maybe it's 2, and that you doubled your viscosity from what you thought it was.
Yeah, so rheologically that could be very different.
Mhm.
Mhm.
All right, we are all out of samples to test.
Yeah.
Oh,
So-
man.
So, so I think we'll pause for a moment and see if anyone has any questions on the m-VROC or RioSense in general. And while we're waiting to see if anyone does have questions, I just wanted to thank all of our customers out there. And maybe Rick, you have a shout out to your customers too, and Ashley and Wayne. We appreciate your business all year long and all of the participation in our educational content. So thank you so much, and we are wishing you certainly a great holiday season.
With lots of coffee.
With lots
Yes.
of coffee, yeah. Big shout out to all of our customers. We like to have a close relationship with our partners. And so we continually try to engage our customers as much as we can. Yeah, we're partners. We're not just here to sell you an instrument. We're here to help you.
So I have a little joke.
Wayne has
What happens if you put coffee in a washing machine? What do you get?
I don't know.
No, I don't know.
A viscous cycle.
But
Oh, God.
Thank you, Wayne.
That's my dad joke.
Now I understand why people don't like my joke.
Okay, well, thank you everyone for joining us, and happy holidays from everybody at RioSense.
Thank you.
Hi guys. Cheers. Happy holidays.